Hello everyone. As in the previous topic, we already had discussed about the Daubernier triads and the Newland's law of octave. That how these scientists were classified the elements, arranged the elements in different manner. And now we are with a very different, important and a very, you can say, a very important scientist who classified the element into a different way, and his name was Mendeleev, Dmitry Ivanovich Mendeleev. In short, he is known as Mendeleev. So Mendeleev started to classify the elements, and at that time there were 63 elements, known elements, that were 63. So there's a very interesting story behind that when Mendeleev were classifying the element, then he wrote all the properties of element on some cards, and in that room where he was working, in that particular room, on the wall of that room, he pasted all the cards according to the similarity on the basis of their properties. And it was surprised that all the elements were arranged automatically in their increasing atomic masses. So Mendeleev also arranged the elements on the basis of their increasing atomic masses. So what was the Mendeleev's periodic law? That means like Daubernier triads and the Newland's law of octave, in the same manner Mendeleev's proposed a statement, and that is known as Mendeleev's periodic law. Mendeleev's periodic law states that the properties of elements are periodic function of their atomic masses. That means when elements are arranged on the basis of their atomic masses, then they repeat their properties. It means the properties is their periodic function. This one is known as the Mendeleev's periodic table. In this Mendeleev periodic table, he arranged the elements into some groups, like this one is the group, this one is the group, and he provided them the name 1, 2, 3, 4, 5, 6, 7 and 8. So there were 8 groups in the Mendeleev's periodic table. These columns are known as groups, and some horizontal rows, like this one row is first row, second row, third row, fourth row, fifth row and sixth row. So he arranged the elements into columns and into rows. Columns are known as group and rows are known as periods. So he arranged 8 groups and 6 periods. So in Mendeleev's periodic table, there were 8 groups and 6 periods in which elements were arranged. As I told you, that elements were arranged on the basis of their atomic masses and their physical as well as chemical properties. But there are many chemical properties. Out of those many chemical properties, Mendeleev took only 2 chemical properties. First, how elements react with oxygen, that means how they form oxides, and how elements reacts with hydrogen, that means how they form hydrides. So Mendeleev classified the element on the properties, on the basis of the properties of reaction of element with hydrogen and with oxygen, and on that basis he distribute one group into 2 subgroup. One is known as A, this one is the column, and another is known as B, this one is the column. That means one group is divided into 2 subgroup A and B. Every group is divided into 2 subgroup. Every group, you can see here, every group contains 2 subgroup A, B, second A, second B, third A, third B, fourth A, fourth B, like that. And here you can see oxide R2O and RH hydride. So A column, elements are arranged at that time. Elements were arranged on the basis of their reaction with oxygen, how they react with oxygen. And the formula R2O. R means the element. For example, if R is sodium, then it is Na2O. If R is potassium, then it is K2O. So R means that element which is present in this group. And here R means again the element and how it reacts with H. For example, if it is lithium, Li, then LiH. If it is potassium, then KH, related to that. So in the first one column, elements on the basis of their reaction with oxygen, how they react with oxygen, and in B subgroup, how they react with hydrogen, hydride. So in each and every group, the formula is written where R means either it is with oxygen or either it is with hydrogen, where R means elements present in that group. R means element present in that group. So like that he arranged all the elements. And very interesting thing about the Mendeleev's periodic table, that he proposed the idea of groups and periods. That is the very important thing about the Mendeleev's periodic table. Let's move that what are the characteristics. So Mendeleev classified elements in the increasing of their atomic masses and similarities in their properties. Yes, the formula of oxides and hydrides formed by the elements was also the basis for the classification of elements. So which one elements he took to explain the chemical properties? Oxygen and hydrogen. Mendeleev's periodic table has 6 horizontal rows called periods and 8 vertical rows called groups. You can say column. The groups 1 to 7 had 2 subgroups called A subgroup and B subgroup, as I told you. Group 8 had 3 rows of elements. Elements having similar properties were placed in the same group. There are some spaces left vacant in the table to accommodate the element to be discovered in future. It is very important thing that Mendeleev predicted that some new elements will also be discovered in future. So he left some place at that time for future discovered element. So merits of Mendeleev's periodic table means what are the good points of the Mendeleev's periodic table? Elements were classified on a more fundamental basis on their atomic masses and properties. Yes, on the basis of, because earlier we observed it that either it was Daubernier, it was Newland, but they arranged the element on the basis of only and only on the basis of their atomic masses. But Mendeleev's arranged with atomic masses, but some properties were also there. Spaces were left vacant to accommodate the elements to be discovered in future. Obviously, that was a very good point. It could predicted the properties of the elements which helped in the discovery of new elements. Yes, there was a prediction about the properties of those elements which were not present at that time, but they could discovered in the future. The inert gas element discovered later. Yes, at that time inert gas elements were not discovered, but later when they discovered, they could be placed in a separate group without disturbing the table. Without disturbing the Mendeleev table, a separate group can be formed for inert gases. So these are the good points of Mendeleev's periodic table. Like you can say merits of Mendeleev's periodic table. But there were some defects also, and due to these defects, Mendeleev's periodic table was rejected. Some elements are not arranged in the increasing order of their atomic masses, like cobalt is placed before nickel. Yes, I want to show this. Cobalt, it is having atomic mass 58.93 and nickel is having atomic mass 58.71. So nickel has lesser atomic mass than cobalt. So it should be placed before cobalt. But according to property, it did not suit at that time. But it was a defect. Position of hydrogen is not clear because it shows properties similar to metals as well as non-metal. Yes, hydrogen has one electron. It can donate, it can also gain. So that's why it shows property of metals as well as non-metal. But the position of hydrogen was not clear. The position of isotopes of element is not clear. It is very, very important point. As in your 9th class, you already had discussed about the isotopes. Isotopes are the atoms of same elements which have same atomic number but different mass number. Mass number is different of isotopes. So if this table was arranged on the basis of atomic masses, and we will take an example of oxygen. Oxygen, there are 3 isotopes of oxygen. One is having atomic mass 14, one is having 15, and not 14, 15. One is having 15, one is having 16, one is having 18. So can we place at 15 oxygen, at 16 oxygen and at 17 oxygen? No, we cannot place. Same you can take an example of carbon. Carbon is having atomic mass 12, but carbon which is having atomic mass 14 is also available in nature, is also present in nature. So if carbon is placed in this table on the basis of atomic mass, so should we place at the 12 as well as at the 14 number? We should give these two numbers to the carbon. No. One element cannot be placed more than one place. But if this table is arranged on the basis of atomic masses, then how isotopes were justified? No, they were not justified. So that's why this become a defect. In our next session, we will discuss about the new modern periodic table that is accepted. Goodbye everyone.